Hello guys, welcome back to my channel. In this video, we're going to be looking at multiple choice questions that focuses on relations, functions, and graph. And our first question has to do with a graph. Now, which of the following graphs is a function? Now, a function is either a one-to-one relation or a many-to-one relation. Now, from a graphical perspective, we can know if a relation is a function by carrying out what is called a vertical line test. Now, if it is a function, the vertical line will only cut it once at any given point. So let's go right ahead. So if we were to look at the first graph, if I were to draw a vertical line at any point, it will only cut this graph once, as you can see. But look at the second graph. Any vertical line that you draw will cut this twice. Now, of course, we know the answer is A, so we could automatically stop at A. But we just want to carry on to look at the other questions. Now, if you look at C, if I draw a vertical line here, it cuts the graph once. But look at when we draw a vertical line here. It's going to cut the graph an infinite amount of times. If we look at the very last graph, that looks like a parabola turned sideways. If we draw a vertical line, this vertical line also cuts the graph more than once. So the only one here that qualifies as a function would be A, because at any point the vertical line cuts it once. Now here's a second example of a question. Which of the following ordered pair is a function? Now bear in mind that a function is either a one-to-one relation or a many-to-one relation. A one-to-one means that each x value is mapped onto a different y value. Alright? A many-to-one means that more than one x values can be mapped onto the same y value. So it means that the y value can repeat, but the x value cannot repeat. So how do we know which is not a function? All we simply have to do is to look for the scenario where the x value repeats. Once the x value repeats, it is automatically not a function. So if we look at A, all x values are different. We're good to go, that is a function. If we look at B, we notice that the 2 repeats. So we have 2, 8, we have 2, 3, we have 4, 3, we have 1, 4, and we have 2, 8. 2 repeats. We also notice that the 3 repeats. The 3 that repeats is not a problem. It is the 2 that repeats, which makes this a many-to-many relation. So this is definitely not a function. So simply put, the shortcut, if you want to know which of these graphs is not a function, you look for the one where the x value repeats. Alright, here's the next question. If f of x is equal to 3x plus 4 and f of g of x is equal to x, then g of x is equal to. Now, how do I go about finding this? There's a critical property that we need to remember about a function and its inverse. Now, the inverse of any function is a reflection in the line y equal x. So it means that when I put g of x inside of f and the answer is equal to x, which is right here, this tells me that g of x is equal to the inverse of f of x. Good. Now, I don't actually have to go through the entire process of working out this to show the inverse. The inverse means that you normally carry out the opposite operation. So we have 3x plus 4. I want the inverse of that. So because I'm adding 4, I'm going to be subtracting 4. And because I'm multiplying by 3, I'm going to be dividing by 3. So what do I do first? We subtract the 4 first. So we're going to look for the case where we have x minus 4. And then we're going to divide the entire thing by 3. So in this case, my answer is C. So we don't need to manually work out the inverse to actually find what the inverse is. We just need to look at the operation and try to do it in reverse. So we have 3x plus 4. We subtract the 4, which is the opposite, and then we divide by 3, which makes the answer C. Alright, here we go again. The domain of a function f of x is a set -2, 0, 1, 3. The range of the function f of x is. Now, just to clarify that there is a difference between the range and the codomain. Alright, the range is actually a subset of the codomain, and it involves the elements that are mapped onto. Now, because we have the function, we have the domain values. All we have to do is to input these domain values inside of the function and see what happens. So we could input negative 2 first. So we have f of negative 2 would be equal to negative 2 squared minus 1, which is equal to 4 minus 1, which is equal to 3. Now we can look for the ones that have 3 inside. And of course, in this particular scenario, there's only one set of the range values that has a 3 there, and that is C. So we don't even have to go any further. So automatically we know that the right answer is C in this case. If not, if there was a next question that had C as well, we probably would have to input the 0 and look again. So we keep on eliminating the answers. But once you have found the range, which only has the value that you worked out, then you don't have to go any further, right? So because the only one here between A, B, C, and D that has a 3 is C. Now the next question is saying if f of x is equal to 3x plus 4, for what value of x is f of x equal to 13? In other words, what value do I put in the domain that produces 13 in the range? So what we can do is to do exactly what the function says, that f of x is equal to 13. So we can take f of x, which is 3x plus 4, and we equate it to 13. So we're going to have 3x equal, if we subtract 4 from both sides, 13 minus 4. So 3x is equal to 9. We simply divide both sides by 3, so x is equal to 3. So my answer is B. That is one way of doing this question. We could of course use trial and error. Clearly, we know it could never be 43, because 3 times 43 alone would be way more than 13. Then we could move to B, where we tried 3. So we could put 3 in the place of x and see what happens. 3 times 3 plus 4, which would be 9 plus 4, which is equal to 13. And we wouldn't have to go any further, right? So by trial and error, we know that the answer would be B. So you have two options. Either way, it doesn't take really long to work out. Now, what we have here is a mapping diagram. We have our x values, which is really our domain, and then we have our f of x values, which is really our codomain, and more specifically, it is a range in this case. So determine a function f of x. Now, the easiest approach for this question is to apply trial and error. So let us look, for instance, at a 2x minus 1. Now, if we go 2 times 2, which is the first x value, 2 times 2 is 4 minus 1, we do get 3. Okay, so let us use the second x value, which is 4. 2 times 4 is 8 minus 1 is 7. And bear in mind, this is saying that x 4 maps onto 15. So we know that that is out totally. If you look at B, x plus 1, 2 plus 1 is indeed 3, but 4 plus 1 is not 50. So that also is out. Now looking at C, 2 to the 2x minus 1. Let me just write that one. So we're going to have 2 to the 2x. So we're going to have the first thing we have inside there in my domain is 2. So 2 to the 2 times 2 minus 1. That is going to give me 2 to the 4 minus 1. Now 2 to the 4 is actually 16 minus 1, which is 15. Sorry, that's 16 minus 1, which is equal to 15. So it can't be that either. It means that we do not have to try D, because if A, B, and C fails, automatically the answer must be D. And you can check just to make sure if you have a time, but you don't need to check, because we would have ruled out A, B, and C.